Dear students, this is a continuation of our previous lectures on Laplace transforms. Now here we are going to do the problems using the results on Laplace transforms. Previously we have finished problem 1 to 6. Now here we have problem 7. So let us see that now. The question is, find L of AT square plus BT plus C. So as the first step, we will use the linearity property, and this will be equal to the Laplace transform of three different functions can be written as Laplace transform of each function, and it can be added up. That is, this can be written as Laplace transform of AT square plus Laplace transform of BT plus Laplace transform of C, and this is by using the linearity property. And by using the scalar property, we can take the constants out. That is, Laplace transform of AT square can be written as A Laplace transform of T square plus B Laplace transform of T plus C Laplace transform of 1. Because when C is taken out, we will have 1 here. And that is equal to A multiplied with what is Laplace transform of T square? By using the results that we have derived previously, Laplace transform of T square is equal to 2 by S cube. So this will be 2 divided by S cube plus B multiplied with Laplace transform of T is equal to 1 by S square. So these results were derived from the formula Laplace transform of t to the power n is equal to n factorial divided by s to the power n plus 1. So using this, we already derived these two results, which I have already shown in our previous lecture. Kindly watch it and then go through this problem so that it will be easy for you to understand. So Laplace transform of t will be equal to b multiplied with 1 by s square plus C multiplied with Laplace transform of 1 is equal to 1 by S. So this is also by the result that we have found previously. And here we can take the LCM. The LCM will be S cube, and here we will have 2A plus one of the S has to be multiplied in order to get S cube, and so B will be multiplied with S. So BS plus, now here we have to multiply S square, so we will be having plus C S square. So this is the solution for problem 7. Next we will move on to problem 8. Problem 8 is Laplace transform of sin h3t. Now this is just very simply, we can just apply the direct formula and we can get the answer. We know that the result for Laplace transform of sin hat is equal to a divided by s square minus a square. So we will apply this formula here. So at the place of a, what do we have? We have 3 here. So the solution will be equal to 3 divided by s square minus 3 square. More simply, 3 divided by s square minus 3 square is 9. So s squared minus 9. So this is the solution. Next we will move on to problem number 9. So the problem number 9 is find the Laplace transform of t plus 1 the whole square. So now first of all we should apply a plus b the whole square formula and expand whatever is inside. So this will be equal to Laplace transform of, so at the place of a we are having t. So it will be t square plus 2ab. So it's 2t multiplied with 1 plus b square is 1 square, which is 1. So this we have done by using the formula a plus b the whole square. After that, by applying the linearity property, we have to take the Laplace transform of each of the functions. That is, we can write this as Laplace transform of t square, the first function, plus Laplace transform of the second one is 2t, plus the Laplace transform of the third function is 1. So plus Laplace transform of 1. And then we have to apply the scalar property and we have to take this 2, which is a constant, out. So this we will write as it is, plus this constant can be taken out. So 2 Laplace transform of t plus Laplace transform of 1, and that is equal to, now what is Laplace transform of t square? We already know that it is 2 divided by s cube. if you see the results list which I have previously given, you can understand it. So Laplace transform of t square is 2 divided by s cube. So when we apply this, we get 2 divided by s cube plus 2 multiplied with Laplace transform of t is equal to 1 divided by s square. So this we have to write. So 1 divided by s square plus Laplace transform of 1 is equal to 1 by s. So this one we have to substitute here. So 1 by s. We can take the LCM here. So the LCM will be s cube, and here we will have 2 plus 2s plus s square, because we have to multiply s over here so that we get 2s, and here we have to multiply s square, so that we have to multiply s square over here and we get s squared here. So 2 plus 2s plus s square divided by s cube is the solution for this question, that is Laplace transform of t plus 1 the whole square. So here we have problem number 10, which is equal to Laplace transform of this. So first of all, we have to apply the linearity property and separate each functions. That is, we have to find the Laplace transform of each function separately and then add them. So this will be equal to Laplace transform of 5e to the power 8t plus Laplace transform of cos h 3t plus Laplace transform of sin 5t, and further that will be equal to, now apply the scalar property and take the constants outside. So 5 multiplied with Laplace transform of e power 8t plus Laplace transform of cos h 3t plus Laplace transform of sin 5t. These two terms do not have a constant before, so they remain the same. Here alone we had a constant, and so that we have taken out. And so that will be equal to 5 multiplied with, what is Laplace transform of e to the power 8t? We have to apply this result. That is, Laplace transform of e to the power 8t is equal to 1 by s minus a. The value of a here is 8. So that we have to apply. So this will be 5 multiplied with 1 divided by s minus a is what? 8. So s minus 8 plus, what is Laplace transform of cos h 3t? We have to apply this result. Laplace transform of cos h 8t is equal to s divided by s square minus a square. Here the value of a is equal to 3. So it will be s divided by s square minus 3 square plus Laplace transform of sin 5t, for which we have to use the result Laplace transform of sin 8t, which is equal to a divided by s square plus a square. So this we have to apply. So if we use here, we see that the value of a is equal to 5. So 5 divided by s square plus 5 square. And so further when we simplify and write it, this will be 5 divided by s minus 8 plus s divided by s square minus 3 square is 9 plus 5 divided by s square plus 25. 5 square is 25. So this is the solution. So next we have problem number 11. Find L of t square plus 1 the whole square. So that is equal to L of, first of all we will expand this by using a plus b the whole square formula. So when we do so, here a square, the value of a is t square. So t square the whole square will be t to the power 4 plus 2ab. So 2a is t square, b is 1. So 2t square plus 1 square will be 1. So that will be further equal to, by using the linearity property, we can take the Laplace transform of each function separately and add them. So Laplace transform of t to the power 4 plus Laplace transform of 2t square plus Laplace transform of 1. Now we apply the scalar property and we take this constant 2 outside. So this remains the same because there are no constants. But here we have a constant which can be taken out. So 2 Laplace transform of t square plus Laplace transform of 1. And that is equal to What is Laplace transform of t to the power 4? It will be, by using this result, here the value of n is equal to 4. So Laplace transform of t to the power 4 will be equal to 4 factorial divided by s to the power 4 plus 1, which is 5. So 4 factorial divided by s to the power 5 plus 2 multiplied with, what is Laplace transform of t square? We already know that Laplace transform of t square is 2 divided by s cube, which was obtained from this formula, that is Laplace transform of t square, the value of n will be 2. So that will be equal to 2 factorial divided by s to the power 2 plus 1, which is 3. But 2 factorial is 2 into 1, which is 2. So therefore, 2 divided by s cube plus Laplace transform of 1 is equal to what? 1 by s. So we have applied all these formulas. So 1 by s. Further on simplification, this will be equal to, so I will write here. So this is equal to 4 factorial. What is 4 factorial? 4 multiplied with 3 multiplied with 2 multiplied with 1. So 4 3 times is 4 3 times is 12. 12 2 times is 24. So it will be 24 divided by s to the power 5 plus 2 2 times is 4. So 4 divided by s cube plus 1 by s. We can either leave it as it is, or also we can simplify it even more by taking the LCM, and the LCM will be s to the power 5. So we will have 24 plus, we have to multiply s square over here. So the same will be multiplied here. So we will be having 4s square plus, here we have to multiply s to the power 4. So same will be multiplied here. So it will be s power 4. So we will be having s to the power 4. So this is the solution of problem 11. So next we will deal with problem 12. So here we have problem 12. We have to find the Laplace transform of these functions. So this can be written by using the linearity property. It can be written as Laplace transform of cos hat plus Laplace transform of sin 2t plus Laplace transform of t cube. We do not have any constants in multiplication, and so there is no need of applying the scalar property. The next is we have to find Laplace transform of cos hat. Now what is the formula for this? We know that the result is given by s divided by s square minus a square. So s divided by s square minus a square. Since we have a over here, we can use a here also. So plus, now Laplace transform of sin 2t. So what is the formula, the result for Laplace transform of sin at? It is equal to a divided by s square plus a square. So while using this, at the place of a, what do we have here? 2. So we will be having 2 divided by s square plus 2 square plus, next we have Laplace transform of t cube. So we will be using the formula Laplace transform of t to the power n equal to n factorial by s to the power n plus 1. Here we want to find Laplace transform of t cube. So the value of n is 3. So Laplace transform of t cube will be equal to 3 factorial divided by s to the power 3 plus 1, which is 4. And so what is 3 factorial? 3 into 2 into 1 divided by s to the power 4. So 3 2 times is 6, and so the solution will be 6 divided by s to the power 4. So therefore the final answer will be s divided by s square minus a square plus 2 divided by s square plus 2 square is 4 plus 6 divided by s to the power 4. So hope you have understood all the problems of this lecture. In our next lecture, we will see how to find the Laplace transform of terms like sin squared 2t, cos squared 3t, sin cube 2t, cos cube 3t. All this will be done by using the identities from trigonometry. So we will be learning Laplace transform of those functions where we will be using trigonometric identities to solve them. Thank you.